Welcome to the video for C2.2.1. This is the second part in which we're going to talk about the physical properties of metals and non-metals. So the last lesson was the chemical properties of metals and non-metals. And in that previous lesson, so our previous knowledge that we need to access this lesson is that metals are found on the left-hand side of the periodic table and non-metals are found on the right-hand side of the periodic table. Now, of course, when we say left and right, it's not like an even divide down the middle. There's more metals than non-metals, so the metals are really kind of on the left-hand side and the middle of the periodic table. And last lesson, we discussed that metals and non-metals have got different chemical and physical properties. So on to what we need to know today. So our learning objectives are to describe the physical properties of metals and non-metals, and to explain, using these physical properties, how we can distinguish between metals and non-metals. So there's some keywords here that we need. So your first task is to copy these down and then add a picture to help you remember what that actually means. So I'm going to talk you through these and I'll give you a couple of examples of pictures I might draw. So for physical property, that's all of the terms below that are physical property. So physical property is a feature of a substance, so a chemical, that we can either observe, so we could see, for example, or we might smell something, or we might measure it with an instrument. So we might measure its melting point with a thermometer, and we might observe its colour by looking at it. So all the physical properties that we need to consider are listed here. So brittle. So if something is brittle, it means that when we hit it with something, it will crack or shatter. So if I wanted to draw a picture to help me remember that, I could have a picture of a lump of the element with like a hammer, and showing that when you do that, then have an arrow to show that it then breaks into two pieces. The opposite of brittle is malleable. So malleable means that when you hit it, instead of cracking or shattering, it either bends or it changes shape, or it's hammered into a different shape. So for that one, I might show a lump of material and a hammer and then show that it's deformed and it's changed shape. So ductile means that that substance can be drawn into a long, thin wire. So if we think of like paper clips, the metal that's used for that is ductile, which allows it to be drawn into a long, thin wire so we can then use it as paper clips. Sonorous means that if I hit it, it makes a ringing sound. So think of like a bell. When you hit a bell, it makes a ringing sound. So the material used to make the bell is sonorous. Lustrous means that that substance is shiny, so it reflects light and back into our eyes and it's shiny. The opposite of that would be dull. When we talk about conductors and insulators, there's two possibilities here. We could be talking about electrical energy, or we could be talking about thermal energy, which is heat energy. So if I talk about something being a good conductor of heat, then that means it allows heat to pass through it, to travel through it. If I talk about a substance being a good conductor of electricity, that means that it allows the electricity to pass through it easily. An insulator is the opposite. So if a substance is unable to carry electrical current, then we call it an insulator. And if something prevents heat from traveling from one end of the substance to the other, then we call it an insulator. So hard and strong terms that people get mixed up. So if something's hard, it means it's not easily scratched. So one of the hardest substances is diamond, so you can't scratch diamond with anything else other than another diamond. So if something's hard, it means you can't easily scratch it with another piece of material. Strength, or how strong something is, means that it can resist a force. So if something's strong, it resists force without being broken or deformed. So a good example is the difference between hard and strong is glass. So glass is quite hard, it's not easily scratched, but it's not very strong. If you hit it with a hammer, it would easily break. And last term, high density. So if we talk about density, you've probably met this in physics. Density just means the mass per unit volume. So if it's high density, it means it's got a lot of mass per unit volume. Right. So hopefully you've copied them down into your book and you've drawn a little picture to help you remember that term. Yeah, extension task, if you want to do it, is highlight, before we go into the next slide, which will kind of give you the answers, highlight in your notes which of those you think would be typical for a metal. So what we need to do next is copy this table into our notes. So this table gives us the typical properties of metals compared to non-metals. So appearance-wise, metal elements are shiny, non-metal elements are dull. In terms of melting point, for metals, they're normally high, and for non-metals, they're normally low. And this links with the state of room temperature. So for metals, all of the metal elements apart from mercury is a solid at room temperature, and that's because they've got high melting and boiling points. Gallium's got a reasonably low melting point as well if it's solid at room temperature, but if you put it in the palm of your hand, it's low enough that your body heat would melt it. So there are exceptions to the high melting and boiling point, which is why it says usually high, not just high. For non-metals, then about half of them are solid and about half of them are gases. There is one liquid, which is bromine, but it's pretty much evenly split between the solids and the gases. So in terms of malleable or brittle, so metal elements tend to be malleable, whereas non-metal elements tend to be brittle. And metal elements tend to be ductile, whereas non-metal elements tend to be not ductile. Now, in terms of conductors, both heat and electricity, metal elements tend to be good conductors, and non-metal elements tend to be poor conductors or insulators. Now, there is an exception to this, which is carbon, which has different forms. So it has diamond, which acts as a typical metal, non-metal in terms of electricity, because it doesn't conduct electricity. But there's also graphite, which does conduct electricity. Now, you'll learn more about this when we do about the different forms of carbon, the different allotropes of carbon in a later lesson. And not included in the table, but also important, metals are also usually hard, strong, and have a high density, whereas non-metals would normally be softer, not as strong, and have a lower density. So second task you need to do is answer this exam question. So the exam question is asking you, most metals have these physical properties, so shiny, high melting point, high boiling point. Write down 2 other physical properties that most metals have, and you can look back on the notes that you've made to help you with this. And then pause the video, answer this question, and then the answer's on the next slide. Okay, so it's a 2-mark question. There's 1 mark for each of hard, high density, you could have had either strong or high tensile strength, so that means that it's strong when you stretch it. Good conductors of electricity, good conductors of heat, malleable, ductile, or sonorous. Now, if you look at the allows, these are always interesting. So allow statements in mark schemes mean that it would give you the mark, but it's not as good an answer. So it's better, if you get one of these, it's best to write yourself a note as to what you would have to do the perfect answer, because sometimes the allow bits are different depending on how different students have answered the question. So if lots of people have written good conductors rather than good conductors of electricity or good conductors of heat, then they might give you a mark. But if not many people do, then they wouldn't. So you could have had good conductors for 1 mark. You could have had hammered into shape rather than malleable. The ignore, so something called the list principle in exams, which means that if you write something wrong, it cancels something that's correct. If it says ignore, it means that that's not counted as a wrong answer for that principle. So if you wrote bendy or flexible, it would be ignored. You wouldn't get a mark for it, but it wouldn't cost you a mark. Likewise, if you wrote durable, tough, hard-wearing, or long-lasting. Right, the last task you need to do, unless you're doing the extension, is use what you've learned to classify those 2 elements. So I want you to look at those 2 pictures, think about what those elements might be like based on what you can see, and then explain why you think that's a metal or a non-metal. Now, the diagram on the right is a bit tricky to see what it is. So it's not actually solid. It's a glass vial which has got a reddy brown liquid in. Okay, once you've done that, there's just the extension task left. So if you want to do the extension task, you don't have to do this. All you need to do is construct a similar different mind map for metals and non-metals. So if you've not done this before, the 2 little circles, one you write metal in, and the other you write non-metal in. And then something that both of the metals and the non-metals share, you would put in the middle where you've got an arrow from each of those circles. So for example, for this, you might put some are solid because some metals are solid and some non-metals are solid. You could also just put that they're all elements because they are. And then the ones on the outside that only have 1 arrow going to them are things that are different. So you might put good conductor of heat for the metal one, for example, whereas for the non-metal, you put insulator. Okay, that's the end of the lesson. Thank you for listening. See you next time.